and we will be using it as we move on. We will now talk about accelerated motion. Now tell me, what is acceleration? I'm sure most of you experience acceleration. When you put your foot down on the accelerator of your car, the speed of the car increases. So what is acceleration? What causes acceleration? Acceleration is caused by a change in velocity. If the velocity remains uniform, there is no acceleration. So acceleration is caused by a change in velocity. Well, acceleration is caused by a change in velocity. And we will represent acceleration by the lowercase a, and this a is caused. Now how do you define acceleration? It is caused by a change in velocity, and we will define acceleration as the rate of change of velocity. Rate of change of velocity. What is the meaning of rate of change? Rate of change is change divided by that time. So how would you write an equation for acceleration? Acceleration equal to change in velocity divided by change in time. In other words, if the velocity changes from an initial value v1 to a final value v2, the change in velocity will be v2 minus v1, and this change happens in a time t2 minus t1. Then acceleration is v2 minus v1 divided by t2 minus t1, and we can write it like this. v2 minus v1, I can write it as delta v, and t2 minus t1 is delta t. So acceleration is delta v divided by delta t, the change in velocity divided by the time. Alright, can you tell me, what is the unit for measuring acceleration? Tell me, what is the unit for measuring change in velocity? Velocity is measured in meter per second. What is the unit for measuring change in velocity? Well, I know some of you are having trouble there. Well, if money is measured in dollars, what is the unit for measuring the change in the amount of money? Well, you went to the mall with $500 in your pocket and you came back with $20. What is the change in the amount of money in your pocket? It is $480. Is that right? So if the velocity is measured in meter per second, the change in velocity delta v also is measured in meter per second. And so what is the unit for acceleration? It will be meter per second divided by second. Is that right? That will be meter per second divided by second. What is that? What is meter per second divided by second? That will be meter per second squared. And we write it like this, meter per second squared. So acceleration is measured in meter per second squared. That is the unit of acceleration. Okay. Well, acceleration A equal to delta V divided by delta T. Acceleration is the measure of the rate of change of velocity. Now, since acceleration is the rate of change of velocity, the instantaneous acceleration, can you tell me, how do you find the instantaneous acceleration? Since acceleration is defined as the rate of change of velocity, the instantaneous acceleration is the derivative of the velocity function. Is that right? Yes. So, instantaneous acceleration is the derivative of the velocity function with respect to time, and we can write it like this. Acceleration, instantaneous acceleration, is the limiting value of delta v over delta t when delta t approaches 0, and that is what we call the derivative of the velocity function with respect to time. So acceleration is the derivative of the velocity function. Now if you know your calculus now well, if you integrate velocity, what do you get? You get displacement. And you find the derivative of displacement, what do you get? You get velocity. So all these can be expressed very easily using the notations of calculus. Look at this, the derivative of velocity with respect to time. But velocity itself is the derivative of the position function. And therefore, acceleration is the second derivative of the position function with respect to time. I'm sure you are familiar with this notation. You see, the derivative of velocity. Velocity itself is the derivative of the position function. So, this is the derivative of the position function. The second derivative of the position function. It's very important that you know these notations. So, acceleration is measured in meter per second squared. We just talked about that a while ago. Let's now look at the plot of velocity against time in this case. Can you talk about this? The initial velocity of the particle is v1 and the velocity increases steadily. What does that mean? It increases steadily. The increase is uniform. You can see a straight line until the velocity reaches v2. And if that happens in a time t, then v2 minus v1 over the time is the definition of acceleration. In other words, if you draw a graph of velocity against time, and if that graph is a straight line, then the slope of that graph is a measure of the uniform acceleration. You see, in this course, we will only use uniform acceleration. We will not look at particles moving with non-uniform acceleration. We will only look at uniform acceleration. That means velocity against time graph will be a straight line, and the slope of the graph will give you the acceleration. Now, this is a positive acceleration. How do you know if it is a positive acceleration? An acceleration is positive if the velocity keeps on increasing, right? So this is a positive acceleration. The slope of the velocity against time graph is the positive acceleration. Now look at the next graph. This is again a graph of velocity against time. What is the difference here? The particle starts with an initial velocity, and its velocity decreases steadily until it reaches a very small value. The velocity is decreasing. Now, what kind of slope do you have for this graph? This time, the slope of the velocity against time graph is negative. It indicates that the velocity is decreasing. So, when an object picks up speed and keeps on increasing the velocity, the acceleration is positive. Whereas, if an object from a higher speed reduces its speed, the acceleration is negative. So, I will ask you, I think in one of the assignments I have asked you, write a paragraph about negative acceleration. So, What does negative acceleration mean? A negative acceleration in this context means the object is slowing down. In other words, the direction of acceleration is opposite to the direction of velocity. Now, I will also talk about a negative acceleration if the acceleration is in the downward direction. You see, we are used to understanding a downward direction as negative and an upward direction as positive. So, if this object is allowed to fall, it actually falls with an acceleration. Is that acceleration positive or negative? We will use it as negative, not because the speed of the object is reducing, but because the acceleration is directed in the negative y direction. You see that? So, we will use negative acceleration in those two senses. But most important to understand is that when the acceleration is directed opposite to velocity, when you brake your car, the velocity is directed forward and the acceleration is directed backward. The car is going to stop. That is a negative acceleration. Okay, let's do a small problem. A car starts from rest and accelerates uniformly for 5 seconds until its velocity reaches 10 meters per second. What is its acceleration? Well, that is a fundamental problem which can be done very easily by using the definition of acceleration. Now, a car starts from rest means that its velocity equal to 0 when you start counting your time, or we say v equal to 0 when t equal to 0, and v equal to 10 meters per second at the end of time 5 seconds. Therefore, what is delta v? The change in velocity. The change in velocity is the final velocity minus the initial velocity. The velocity changed by 10 meters per second. Now, this change in velocity occurred in what time interval? Delta t equal to 5 minus 0, that is 5 seconds. What is the definition of acceleration? Acceleration is delta v divided by delta t. The change in velocity divided by the change in time. That will be 10 meters per second divided by 5 seconds. That will be 2 meters per second squared. It means every second the velocity of the object increases by 2 meters per second. That's the meaning there. Acceleration is positive, velocity is increasing. That means when time t equal to 0, the velocity is 0. When t equal to 1 second, the velocity is 2 meters per second. When t equal to 2 seconds, the velocity is 4 meters per second. At the end of 3 seconds, the velocity is 6 meters per second. Every second, the velocity increases by